So hey everyone, I am Greg Skril.eth with ENS Labs, and today we're going to be talking about ENS identity in your apps. So quick overview, we're going to be talking about what is ENS, why is it important, what are the different types of ENS names, how does it work, and then lastly some resources for the hackathon this weekend. So first of all, what is ENS? In a single sentence, it's a decentralized permissionless naming protocol that lives on Ethereum and scales to the entire internet. The really high-level overview is that we turn complex hex addresses into human-readable names. So you might be familiar with DNS, which turns IP addresses into normal web domains, like this number to google.com. The problem in crypto is even worse, and so we're turning these long hex addresses into simple, readable names like nick.eth. The goal is that anywhere you read or write an address, you should be able to use an ENS name. And so this is in the context of reading on the left-hand side. You can see Etherscan, a live ledger, seeing that Luke.eth sent something to me, Greg Skril.eth, which is clearly a lot more clear than me, Greg Skril.eth, sending something to OX554F, and so on. And then in the writing context, this is MetaMask, me sending Ether to Greg Skril.eth instead of having to copy and paste an address. Really just, again, human-readable names. And this works in two different ways. So there's forward resolution, which is going from a name to an address. So for example, what you saw in MetaMask of typing in nick.eth and getting this long address. And then there's also reverse resolution, which is I, as the owner of, say, OXB8 in this case, I claim that I want to be known across different apps as nick.eth. And that means when I sign into different apps, it can kind of recognize me as that, and it becomes this portable Web3 identity. And this is what really takes ENS just from a simple Web3 username to really a Web3 profile and, again, a portable identity. So all of these are different dApps, not built by ENS, but that recognize my name as part of my identity because, again, it is a portable Web3 identity. And just to really hone in on the idea of a profile versus a name, most people think it's just name.eth and then some ETH address for mainnet Ethereum and call it a day. But really, it's important to highlight that there's a lot of other metadata attached to a name as well. You know, I have a description, a location, and an address for different types of chains as well. So it's just important to realize that it's really an ENS profile, even though we call it an ENS name very often. Another representation of this is just when I sign into different apps across Web3, a lot of them will recognize me as my ENS name. Again, it is this portable Web3 identity. So this is Snapshot and Matcha. Again, two apps not built by ENS. So we understand what it is at a high level, and we're going to keep going a little bit deeper. Why is it important? So I stole this slide from our designer the other day because I think it's important even for developers to understand what the goal of ENS is. You know, at the surface, it looks like we just sell these names, but really it's a UX business. Our role is to help make complex and scary interactions feel better across the internet. This is Ethereum right here, you know, the Ethereum logo that we all know and love, and the ENS logo is literally meant to be a wrapper around Ethereum. It is to improve the UX of Ethereum and the greater crypto ecosystem. So now into some misconceptions. There are a lot of different types of ENS names, and most people think it's just .eth, but that is not true. There is one ENS native TLD, and that is .eth, which has been most of what I've been saying so far, but you can also use almost any DNS TLD in ENS as well. So a .com domain, .xyz domain, and so on. These all work as ENS names. But there are some differences. So .eth is really the top dog in decentralization for on-chain domains. It lives on mainnet Ethereum, it is fully decentralized, controlled by ENS DAO, and there is an annual fee to make sure that the namespace stays healthy. Whereas on the DNS side, a lot of these things are not true. It's not entirely decentralized, it doesn't live on Ethereum necessarily, and there's no protocol fee. So it's just a matter of trade-offs, but the point here is that ENS respects existing internet infrastructure and is not just limited to .eth in this closed system. We really try and bridge the gap between all of the internet. And the flexible registration options I can dive into a little bit later, but basically DNS names can be used for free in the ENS ecosystem, whereas .eth names, at least second level .eth names, cannot. So both of these type of names can be used in a number of different ways, namely subdomains and issuing something like sub.name.eth under just name.eth. And these names can be off-chain, which includes on layer 2s. So this will get into more how it works. But again, in these off-chain or layer 2 names, it's just a flexible way of issuing names that, again, have no protocol fee, gives developers infinite flexibility into how they want to issue these different names, and again, issue basically identity to their users across their apps. And it is powered by CCIP read or EIP 3668, which I have another slide on in a bit. Just to give you some context of really who uses this or where you may have seen it in the wild so far, it's used by Coinbase, Uniswap, POAP, and a lot more, to a total of 5 million plus names. And so it's getting well adopted and just increasing over time. So now, how does ENS work? This is the more dense part. So the ENS registry is just a smart contract on Ethereum. And at a very simplified level, it stores names side-by-side resolvers. So you see here is my name, and my resolver is OX4976, so on. This is a smart contract that tells different applications how to resolve my name, how to resolve different data associated with my ENS profile. CB.ID here, this is the Coinbase example, and they use their own resolver. And again, teamnick.eth, which has its own resolver as well. Multiple names can use the same resolver, and most do use the same resolver, but the resolver spec is an open standard that anybody can build their own, and it's how you do a lot of this flexible, interesting stuff with ENS subnames. So diving into each one of these and really what it looks like. First, we have the resolver that I use for Greg Skril.eth. This is the public resolver, which is just what we call the default resolver. And basically, in that, you can store an object of addresses and an object of text records, among other things. And again, I just want to highlight, this is a simplification of it. It's not actually storing like the string ETH side-by-side in address, but good enough for demonstration purposes. And so this means I can store the address for any blockchain in my ENS name, which a lot of people think is just for Ethereum. And so that's not true. You can see here, I store an ETH address, a base address, and a Bitcoin address. And the base versus ETH address is important to note because account abstraction doesn't guarantee that you have the same address on every chain. And so ENS is flexible enough to allow you to set a specific address per chain that you want to use when resolving your name. And text records are a similar thinking of just an arbitrary data store for key value pairs. So there's an avatar text record, there's a description text record. These are kind of standard and shown across many apps. But also you can put ABC as a key and XYZ as a value, and you can use that as a developer to do any sort of interesting thing that you'd like. Now getting into off-chain resolvers. So off-chain resolvers are interesting because when you go to resolve something for a name, so if I go to resolve an ETH address for cb.id, or the stars to indicate any subdomain under cb.id, from the smart contract perspective, you actually get an error. And this error is CCIP read. And then the star is wildcard resolution. So I'll explain both of these steps. Basically, wildcard resolution is an ENS spec that defines how to find the resolver for a subdomain that might not exist on-chain. So for example, you can go into the Coinbase wallet app today and register name.cb.id. And when I say register, that's just like adding a record in Coinbase's database, but it becomes instantly accessible across all of Web3. So you can use this in MetaMask as soon as it's created in Coinbase Wallet, even though it's not on-chain. And the way this works is MetaMask would look for the resolver of name.cb.id. That wouldn't exist, and then it looks for the resolver of cb.id, and that does exist on-chain. Then it would resolve name.cb.id through the resolver of cb.id, and this is wildcard resolution, the ability to resolve subdomains under a parent name. And then CCIP read is the ability to fetch off-chain data securely from a smart contract. And so basically, once it finds the resolver of cb.id in that recursive process, it will reach out to the gateway URL that Coinbase has specified, which is basically just an API, and it will return a response, and then the client, so MetaMask in this case, will verify that response and return the answer, which is an ETH address or a Bitcoin address or anything like that. So these two things in combination make it possible to issue free names to any user on ENS. And this is a lot of the integrations we're seeing these days because it really allows developers the ultimate flexibility to issue names for free to all their users. And then lastly, let's take a look at the layer 2 example. So there's a name teamnick.eth, and then there are subdomains under that. Those subdomains don't exist on mainnet Ethereum, and so when MetaMask goes to resolve something, so let's use name.teamnick.eth as an example, it won't exist, and it will find the resolver of teamnick.eth and end up at the same error. Because these layer 2 resolvers are powered by something called the EVM Gateway, and that's a library that we used, or that we built, that allows you to verify layer 2 state from a layer 1 smart contract. And so what's actually happening here is that they both use CCIP read, so they both revert with that off-chain lookup. And the difference between cb.id and teamnick.eth is that cb.id reads from an off-chain database, or really any off-chain data source, and then it has a signature verification, or really any arbitrary verification in the resolver smart contract. Whereas the EVM Gateway allows you to minimize the trust required in this process. So instead of reading from a database, it reads from a layer 2 RPC, and then the state of that layer 2 is verified on the layer 1 contract to make trustless layer 2 subdomains. And so these are kind of two different approaches that teams are taking nowadays, and EVM Gateway is a newer one that I think we'd like to push. So that is two kind of like in-depth approaches to building ENS subnames and different types of names. This is a link to a Notion doc that has resources and links and contact info and code snippets and all that stuff. If you're building this weekend on any of the things I've talked about or integrating any other sort of ENS implementation to your app, should have info for you, and we also have a booth to help. I'll leave this up here for a second. Cool. And then if you're using those resources, we have 10K in prizes for the best ENS integrations. So this is for nothing specific. There's not any super specific track. It's just generic best use cases of ENS. And this is because we think of ENS as base layer infrastructure. You know, if you're building a really good application that has a need for usernames, which most do, implement ENS in a really creative and a natural way, and that is eligible for a prize. Or if you're really interested in building ENS-specific infrastructure, like maybe certain gateway tooling or certain smart contracts, then that alone can qualify as well. So we're keeping the gate open. Any interesting integrations or implementations of ENS are eligible for prizes. But that is what I have for you guys, and I'm happy to take any questions.
So the statehood verification you mentioned, so I presume it has to be L2, which is anchored on Ethereum mainnet, right?
Yes. So the EVM Gateway is a few moving pieces. There's a contract on layer 1, mainnet Ethereum, and there is a CCIP read gateway, which is basically an API. And then there's a contract on the layer 2 that the gateway is reading from, basically. And the flow is that the layer 1 smart contract will revert with a CCIP read lookup that will hit the gateway with certain data that you're requesting, so a specific storage slot that you want to read from the layer 2. And then that will give it back to the client on layer 1, and there's a callback function as part of CCIP read that can basically verify if the storage slot returned from the RPC has been kind of like committed to mainnet by the native layer 2 bridge or the layer 2 like state root. And if that checks out, if it works, then it will return the valid response. Otherwise, it will fail. And so in this case, it's trust minimized because the gateway cannot lie about the response from layer 2. It can't return invalid state. Otherwise, the contract will not verify the data. But it's still not fully trustless because the gateway operator can just turn off the gateway. So it's a different trade-off from Coinbase and Teamnick in the examples that I showed, but further along the path of like a trustless layer 2 name.
So it's like all L2s, do they use same Patricia trees as on L1? Is this what made it possible?
The same what strategies, sorry?
So the state root, is it always a Patricia tree, like the same format of tree that we have on L1?
Yeah, there are different implementations for different layer 2s, especially like ZK versus OP Stack versus Arbitrum and all these other things. We have the library called the EVM Gateway which currently supports OP stack chains, so Base, OP mainnet, Zora, and so on, and Arbitrum as well, and maybe one others. And then some of the ZK stuff is a bit more complex and still in the works, but generally they're not all identical, but they have some overlapping characteristics that'll make it possible.
Nice, very nice work. Thank you.
Thanks. We have time for one more question, I think, if anybody has.
You gave an example of cb.id, and you mentioned that they have their own resolver.
Yep.
The resolver address is different. So does cb.id need to be renewed, make a payment and renew like we do for .e domains?
No, so cb.id is kind of a combination of using DNS in ENS and using off-chain names. And so as long as they have the domain, the DNS domain cb.id, they don't have to pay any fees to ENS at all. And they issued effectively 4 million names for free.
Got it. Thanks.
Yeah. Cool. I think we're out of time.